Okay, so here we have a problem about bacteria. It says a population of bacteria doubles every hour. If the culture started with 10 bacteria, graph the population as a function of time. So according to our model, A of t is equal to 10, because that's the initial part. That's the A naught right there. E to the k t. Now, we know a little bit. We know it's going to double after an hour. Let's look at a little table of values here. It should be t, and then A of t. So when I have no time going by, I'm starting with 10. But after 1 hour, it's going to double to 20. After 2 hours, it's going to double to 40. After 3 hours, it's going to double to 80, and so on. They do two things in the textbook, and I wanted to go over both of them because I thought they were important. Okay, look at this point right here. If I were to put in a 1 for t, then A of t would be 20. So after 1 hour, bacteria double. And this allows us to solve for k. If you look at that formula now, we only have the one variable, k. We divide both sides by 10, and you get 2 equals e to the k. Now you can change that to a natural log. So it's the natural log of 2 equals k. This then is the constant for the formula. So if they ask for the formula, let me scroll a little bit, you could write A of t, so the function in time, is equal to 10 e to the, and then you can just put natural log of 2 times t. And, you could put that in brackets or parentheses if you wanted to. That might be helpful. It's an exponential graph, and it's going to be doubling, right? So it's going to be going up quickly. We're going to see that when we go to graph it here in a sec. That natural log of 2, it's just a number. You can get a decimal approximation. Now you'll notice that in some of the formulas they'll have a decimal approximation for k. But if I put natural log of 2, then that means it's an exact answer. Okay, now let's look at the graph. So 0, 1 hour, 2 hour, 3 hours, 4 hours go by. And how much is our population? Well, it's going to go up pretty quickly. Let's say I'm counting by 20s. 20, 40, 60, 80, 100. Okay, that's enough. All right, so I should label so we know 20, 40, 60, 80, 100. Okay, and then this would be then the the bacteria. How many? Number of bacteria. And then time is over here, and we're measuring that 1 hour, 2 hours, 3 hours, 4 hours. We're starting at 0. We have 10 bacteria. Then after an hour, it went up to 20. After 2 hours, it goes up to 40. After 3 hours, it's going up to 80. 80. And after 4 hours, it's going to go up to 160. Higher than that probably, but I ran out of room. So you can see that exponential curve going like that. Okay? And there's probably a better picture in the book.